Okay, what we're going to talk about right now, the topic for this video is zero exponents and negative exponents. So we're gonna use the quotient of a powers property and the definition for properties. Definition for exponents and powers. Both of these properties, I think, they're not that hard to see what's going on, but it's very easy to get confused with these. It's one of the most important things is to make sure you understand with both of these that you're not multiplying by a zero. You're not multiplying by a negative number. So an exponent, remember, refers to the number of times that that number is multiplied. And so there are a couple of ways that you can look at zero exponents. One of them is if you look at 3 to the second power, for instance. That's used in a multiplication. How many times? 2 times. Now we can write this, and it's going to be helpful to write this as 1 times 3 to the second. So it's in a multiplication, but we're going to use it together with 1. So we can use that because no matter what the number, we can always use 1 as a coefficient. So one of the first things I'm going to do is I'm just going to start off with a division problem. And I'll do several division problems because I want you to make sure you remember a pattern and a property. 3 divided by 3 is what? 5 divided by 5, 1. X divided by x, as long as x is not equal to 0, 1, etc. Right? That means 3 to the second power divided by 3 to the second power is equal to 1. 5 to the 21st power divided by 5 to the 21st power is equal to 1. But we also know that by the property of the quotient of the powers property, we can subtract. So 3 to the second power divided by 3 to the second power is the same as 3 to the 2 minus 2. Now, 2 minus 2 is equal to 0. So we know that this 3 over 3 to the second divided by 3 to the second is equal to 3 to the 0. We also know that it's equal to 1. That means 3 to the 0 power is equal to 1. Same thing over here, right? This is equal to 1. We also know 5 to the 21 minus 21. That would be 5 to the 0 power. So 5 to the 0 power is equal to 1. Another way to look at it is with a pattern. So I'm going to start off with, 5 to the third power. Now remember, that's 1 times 5 to the third power. So what do we have here? We're going to use this 5 3 times in our multiplication. If we go 1 times 5 to the fourth, we use 5 4 times. Now we can keep going larger, of course. But I want to go towards 5 to the 0 power. So I'm going to look at this. 5 to the second, 5 times 5. 5 to the first power is equal to 1 times 5. And then 1 times 5 to the 0 power. Remember, we're still going to keep the 1. And then how many? So here, with 5 to the third power, we multiply 1 by 3 5s. 5 times 5 times 5. With 2, it's 1 times 5 times 5. 1 times 5, we only have 1 5. How many 5s do we multiply by 1? None. Now remember, we're not multiplying by 0, so this is our answer. So 5 to the 0 power is 1. So what's the zero exponent property? A to the 0 equals 1. Now there's only one thing you have to be careful with. A cannot be equal to 0. Okay, So 0 to the 0 power doesn't make sense. We cannot use that. So that's the zero exponents property. Now for negative exponents, let's take a look at this. We know 3 to the 5th power minus 3 to the 7th power is going to give us, well, this is, I'm sorry, 3 to the 5th power divided by 3 to the 7th power. So we're going to be dividing here. Now when we divide, the quotient property tells us we can subtract. So you just have to make sure that you don't switch the order. It's 5 minus 7, right? Numerator subtracted by the denominator. So 5 minus 7, that gives us 3. 5 minus 7 is negative 2. So that's where you get a negative exponent. Now the question is, what is that equal to? Well, let's do this problem a little differently. I'm going to go ahead and expand it. So this tells us we have 5 3's that we're multiplying. I'm going to go ahead and put a 1 out front. We don't need to, but it'll help. At least it helps me. And then down here we have 1, 2, 3, 4, 5, 6, 7. So we have 7 3's in the denominator. Now, for every 3 in the numerator and the denominator, we can cancel that out and replace it with a 1. You can go from the front or the back, it doesn't matter. So 1, 1, 1. Now notice we're canceling everything, and as soon as we're done with all the pairs, so that's a pair, all of these, all we're left with in the numerator is a 1. In the denominator, we have 2 3's. But remember, by our definition of powers and exponents, okay, this is the same as 3 to the 2nd power. So what we had before was this, and it's written like this. So basically, negative exponents give you the reciprocal. So a to the negative n is going to be 1 over a to the n power. If you have a negative exponent in the denominator, you can move it up to the numerator. So what I mean by that is, let's say we have 1 over 2 to the negative 3 power. Okay. This would be the same as 1 over 2 to the 3rd power. So that's 1 divided by 1/2. Remember, when you divide by a fraction, you invert and multiply. So it's going to be 1. That's what we're talking about. Oops. So when you divide, you can flip this, right? Invert it. And then multiply. So 1 times 2 to the 3rd power is just 2 to the 3rd. So the shortcut way of looking at this is, if it's in the numerator, move it to the denominator, change the sign. If it's in the denominator, move it to the numerator, change the sign. So we have a to the negative n, b to the negative m. This one moves down below. This one moves up, like that. Okay. If it's positive, it stays where it is. We have this. That one's positive, so it stays where it is. This one's negative, so it moves up. Turns into a positive. Now, we can keep it like that, But if there's nothing else in the denominator other than 1, then we just write it like this. If we had it the other way around, then this one would stay where it is. Okay, now this time we need to make sure we keep that fraction bar. There's a 1 here, right? We need to make sure we keep that. So this one gets moved down, a to the n. This one stays where it is, and now it looks like that.